with the weekend. We coolin' for the weekend. Drop the top and then we out. We do this every season. Sunshades on a sunny day. Doing 80 and we switching lanes. Just keep it cool and chillin' with the bae. Don't call my phone, I hear what you say. Or what you say. We ain't gotta keep this on the low. Don't do it fast, we can take it slow. Show you things that you ain't seen before. Before you go, you ought to know. I won't be catching
Hey guys, what's up? It's your boy Trix. Today we're going to be doing the first part of my Java developer roadmap series, where according to what is it called, Java developer, this roadmap that I found online that basically has a ton of stuff on things that you should just basically know to be a Java developer. This is just me trying to upskill. So below, and this is what it says below, you can find a chart demonstrating the paths that you can take and the libraries that you would learn to become a Java developer. The person who made this chart has tipped for everybody what shall I learn next, as for everyone who asked me what shall I learn next as a Java developer. Purpose of the roadmap is an idea for a landscape. The roadmap will guide you if you are confused about what to learn next, rather than encourage you to pick what is hip and trendy. You should grow some understanding of why one tool would be better suited for some cases than the other, and remember, hip and trendy does not always mean best suited for the job. So hang on, just give me one sec. Let me just put that screen up. So the way that I interpret this is the ones that are on here that are in yellow are basically things that you should probably know already. So in this diagram, if I just open it up, ooh, that's a big diagram. Open image in new tab. I'm hoping it gives me the raw. There we are. So you can see at the top it's got Java, Gradle, Maven library, and SQL. So in Java, pretty much already know it from university. Gradle, been learning at work, and I've used it in some projects, so I think I'm okay. And then SQL you learn at university. And then there's general development skills, Git, HTTP, HTTPS, data structures. So all of this stuff here you'll probably learn at university or in some like entry-level course. Now we get to the fun bit. So CLI, J Commander and Airline, never touched them before. I've been trying to look for some good tutorials. you can just see in my history it says J Commander tutorial. Passing command line. There's this one by Baildong, but it's not really a tutorial, more like, I want to say documentation. Yeah, when I read Baildong stuff, it's more like a very good explanation. That's kind of like, oh yeah, this is like decent documentation. It's not like a tutorial. So I'm just gonna skip the CLI bit. Probably gonna be a pain in the ass when I come back to it, but I'll be like, but hopefully by the time I come back to it, there'll be something interesting. So the one that we're gonna start with is this dot. If we just skip this one, we're gonna go to this one. Web frameworks and routers. We are going to start with Spring. Why Spring? One of my senior developers in my team recommended it to me, and two, it's on this roadmap. So we're gonna start with Spring. I found some tutorials on Spring. Literally, I have 1, 2, 3, 4, 5, 6, 7 tutorials. So I'm hoping to do this in 7 days. So a week-ish. Obviously, some days I won't be doing this, other days I will. But when I do this, I'll be live streaming it for your entertainment. But yeah, I'm gonna be doing the whole roadmap, hopefully. So I made a bullet point list on my phone. That's basically me saying, hey, I'm going to attempt to do this roadmap. Let me tick off the things that I'm going to do. And my plan is that as I do a thing on the roadmap, when I do a thing on the roadmap, to make it a little bit interesting, I'll only do one in each section, and then once I finish, I'll come back and do another one in each section. So it'll be Spring, then when I get to ORMs, I'll do Hibernate, and then when I loop back through this whole thing, after doing a first run, then I'll do another run of, oh, okay, cool, let's pick up another one in the list. So, like, I'll do Spring, then I'll do SQL Server. I basically already done it through MS SQL, but if there's a Java tutorial thing that's specific to it, I'll do it anyway. Then Cosmos DB, which is Azure's Cosmos DB. Elasticsearch, I used Loki at work, but Elasticsearch I haven't used before, so I could probably just install that on my home server and just give it a go. MongoDB, haven't used it. I have used Firebase though, so similar data structure, no SQL, fine. Hibernate, haven't touched it before. Caffeine, haven't touched it before. Java Redis, haven't touched it before. Then Zap, then Elk Stack, then Socket.io, then OKHTTP, then Bean validation. JUnit I've used at work, so I don't really need to learn it again. Actually, I can tick some of these off because I use them at work. Hang on. I use Log4j at work. I use Mockito at work. I think I use a Sergio at work. Hang on. I just want to check. I just need... I wish there would be like just a documentation thing. You know what? Yeah, I'm just going to use Baildong for documentation from now on, because at least he has like everything there. So, yeah, I've used it at work. Mock server, I can't remember if I've used it at work or not. I've used Apache Kafka at work. I don't. What does Mosquito use? Does it use RabbitMQ or ActiveMQ? Mosquito. Ooh, what the hell happened there? Hang on. Why are you like this? Why have you loaded with it? The hell? Hang on, is that a thing? I have no idea why it's like this. Let me try resetting this again. Nah, the hell? This loads fine. This website's weird. Stackshare is weird, man. Let me see. Yeah, it's different. Okay, fair enough. Follow micronorm protocol with gRPC. Cool. So the list is not that long. are things that I need to learn, but we're gonna get through it. Anyway, hopefully you enjoyed the ride of watching me fail and struggle through doing all this. And yeah, obviously if it doesn't have a tutorial that I can find, I might skip it. But if you can find a tutorial that I could do, obviously like drop it in chat, drop it in the comments, I'll do it. I've said this before, if you want me to do a video on a specific thing or live stream or whatever, tell me, could you live stream, could you make a video on, and I'll just do it. Sorry if I keep looking away from the camera. I have my OBS up here just to look at chat, so I'll be looking away from camera at time to time. But I'll mainly be looking at this, looking this way, because this is the screen that I'm using when I'm coding. Anyway, so we're gonna start with building REST services with Spring. This should be like a 2-3 hour tutorial. 괜찮아. It'll be easy. Anyway, let's get started. Let me just put my phone over there so I don't get distracted. There we go. REST has quickly become the de facto standard for building web services on the web. Because they're easy to build and easy to consume, there's a much larger discussion to be had about how REST fits in the world of microservices. But for this tutorial, let's just look at building RESTful services. Why REST? REST embraces the precepts of the web, including its architecture, benefits, and everything else. There's no surprise given its author, Rory Fielding, was involved in probably a dozen specs which govern how the web operates, what benefits the web and its core protocol. HTTP provide a stack of features. Suitable actions: get, post, put, delete. What else? Get, post, put, delete. I was gonna say there's update, but nah, put is update. I think those are the only ones that come to mind. Caching, redirection and forwarding, security, encryption and authentication. These are all critical factors on building resilient services, but that is not all. The web is built out of lots of tiny specs, hence it's been able to evolve easily without getting bogged down in standard wars. Developers are able to draw upon third-party toolkits that implement these diverse specs and instantly have both client and server technology at their fingertips. By building on top of HTTP, REST APIs provide the means to build backend compatible APIs, evolvable APIs, scalable services. Let me just move this. Scalable services, securable services, a spectrum of stateless to stateful services. What's important to realize is that REST, however ubiquitous, is not a standard per se, but an approach style that sets constraints on your architecture that can help you build web scale systems. In this tutorial, we will use the Spring portfolio to build a RESTful service while leveraging the stackless feature of REST. That was a lot. I'm happy I have water next to me. As we work through this tutorial, we'll be using Spring Boot. Go to Spring Initializer and add the following dependencies to a project. I use Groovy, Java, artifact name, demo project for Spring Boot. Okay, hang on. Maven, Java, Spring Boot, whichever one, group, add dependencies, add your code, try it. Cool. Web, JPA, and H2. Web, JPA, and H2. Cool. What Java version do I have? Java -3. Java. Java. Oh, for fuck's sake. Swear to God. I should probably update my Java version. Java version. I'll just go to the OpenJDK website, innit? OpenJDK. I didn't realize it was running on Java bloody. Installing. OpenJDK. What is it? 19. Let's see if I can find it. I don't know if it will though. Let me check. What's open source JDK 19. Yeah, I don't know if I'll grab it. Term config Java. No, I can put it there, yeah. Can you tell I haven't programmed in Java in a while on my home machine? Oh no. Let me just go to the website. That's 19.1. You might as well grab it. Let me just chuck it in compressed. Figured. Compressed. Dash. Extract. C. Let me check. Oh, it's not finished yet. Hang on. I saw a meme that helped me remember how to do the thing for extracting. Tar dash extract. There we are. Cool. CD JDK. Let me. Java, I want to get the runtime path. User bin, okay. Noob 64/Java clips SWT cd/etc/java cd/user shared java. That's 1802. Nah, that doesn't exist. Open source update Java. The same Java on Oracle website 2, Java runtime, rename the sham, init outputs, S2, CD downloads, RPM, whatever. Java. Which one has it got? I should have just said OpenJDK in it. Honestly. 19 OpenJDK. There we go. Didn't even need to. I was like, there should be no reason why I have to download it like this. There we go. There we are. Should say 19, no? Why are you saying that? What the hell? I love how this turned into debugging instead of me programming. Mm-hmm. What the hell? Let me check something. I'm gonna do KDE because KDE probably like has a thing to be like, hey, list these packages. Why? Why is it reporting Java 11? Where is it? Come on. Oh, I know what I can do. That should... Realizing that it's not in the right place. Let me do this. Let me pull... Where are you? There you are. I don't know. The hell? Why does the Java version report differently? Weird, man. Where is it? It's this one. I want 19, which is 3. There we are. Fixed it now. God damn it. Painful, honestly. Jesus Christ. Okay, so now I can do 19. Damn. Continue. Change the name to payroll. Artifact demo. Building where services are spring. Let me just turn the brightness on. I mean the light on. Generate. Let me change it to that. There we are. Let me chuck it into learning, programming. Let me just chuck it here. Save, there we go. Let me do cool. So now that I've got that done, change the name to payroll and choose generate process. It will download. Unzip it. Inside you'll find a Maven-based project, including a POM.xml build file. Note you can use Gradle. The examples in this tutorial will be Maven-based. Spring can work with any IDE. That's fine. By no means required, but consider it if you want extra oomph for your keystrokes. Here's a video demonstrating how to get started with STS and Spring Boot. This is general instructions for familiarity with tools. I like Vim, so sticking with Vim. Getting it. Okay. Oh wait. Git checkout -b. Building REST services with Spring. Let me just make a GitHub project. Myself. branches. View all branches. I just want to make a master branch. Master. I'll just leave this as an initial branch. I'll leave it as an initial branch, that's fine. What else? I need to get a get no. Let me just open this up. Get ignore. Ooh, does it already have one? No. Interesting. Alright, fair enough. Okay, so part 1. Let's start off with the simplest thing we can construct. In fact, to make it as simple as possible, we can leave out the concept of rest. Later on, we'll add the rest. Add rest to understand the difference. Big picture. We're going to create a simple payroll service that manages the employees of a company. We'll start employees objects in H2 in memory. In the H2 memory database and access them via something called JPA. Then we'll wrap that with something that will allow access over the internet called Spring MVC layer. The following code defines an employee in our system. So if I go to src main java com example payroll, I just need to make an example dot put employee dot Java, cool. Payroll application, payroll public static void main. There we are. Let me just grab this, copy, paste. Okay. Despite being small, this Java class contains much. Okay, at entity is JPA annotation to make the object ready for storage in a JPA-based data store. ID, name, and role are attributes of our employee domain object. ID is marked with more JPA annotations to indicate its primary key and automatically populated by the JPA provider. A custom constructor is created when we need to create a new instance but don't yet have an ID. With this domain object of finisher, we can now turn to Spring Data JPA. To handle the tedious database interaction, Spring Data JPA repositories are interfaces with methods supporting creating, reading, updating, and deleting records against a back-end data store. Some repositories also support data paging and sorting where appropriate. Spring Data synthesizes implementations based on conventions found in the naming of the methods in the interface. There are multiple repositories that implementations besides JPA. You can use Spring Data MongoDB, Spring Data Gemfire, Spring Data Cassandra, etc. For this, or we'll stick with JPA. Spring makes accessing data easy by simply declaring the following. Employee repository interface, we automatically will be able to create new employees, updating existing ones, delete employees, find employees, one or search by simply or complex repositories. Non-rest SRC, is it called non-rest? Non-rest SRC main Java payroll employee. Now I need to make a employee repository. Employee repository.java, cool. And then I just need to copy this. To get all this free functionality, all we need to do is declare an interface which extends Spring's data JPA's JPA repository specifying the domain type as employee and the ID type as long. Spring Data Repository solution makes it possible to sidestep data store specifics and instead solve a majority of problems using domain-specific terminology. Believe it or not, this is enough to launch an application. A Spring Boot application is at minimum a public site void main entry point and at Spring Boot application annotation. This tells the Spring Boot to help wherever possible. So inside here, this just says at Spring Boot application is a meta annotation that pulls in component scanning, auto configuration, and property support. We won't dive into the details of Spring Boot in this tutorial, but in essence, it will fire up a servlet container and serve up our service. Nevertheless, an application with no data isn't very interesting, so let's preload it. The following class will get loaded automatically by Spring. So load database. So if I copy this, what happens when it gets loaded? Spring Boot will run all command line runner beans once the application context is loaded. This runner will request a copy of the employee repository you just created. Using it, it will create 2 entities and store them. Right click and run payroll application. This is what you get. Okay. So let me run Spring in terminal. Spring tutorials rest. Let me go to learn Spring Boot. What the hell? Quick start guide. Just need to have this up so I know. There we are. Let me just see. Let me just get this going. By the way, so for people who don't know Java, this is just saying when you call this, it's saying in this module, do something. So this is just saying from the Spring Boot module, run this. Yeah, first build is always slow. Should be fine in a little bit. Ooh, interesting, why? Nande? Oh, I need to build first. That's Maven. Cradle. Let me have a look. Where is that supposed to go? Ah, okay. I should just be able to grab from here to here. There we are. Let me see. I'm not sure if it'll run that. This is the only good thing about having an IDE. It'll do this dependency resolution for you. Let's see what it does. Looking good. There we go. Let's have a look. Boot run, there we go. I'm guessing it changed when the new one released, I'm guessing. Just gonna wait for it to build. Just gonna wait for that to run. This is big. Like, it's not even in a Docker container. At work, we use Docker containers, right, to run our applications, because like Docker containers let you virtualize stuff. So if you wanted to run it, you could run it on any platform as long as you have a Docker container, like, as long as you have Docker installed on there. This is slow. Like, unless I've done the wrong thing. This is in Gradle boot run. So it is just this slow. That's a 2-minute build. Oh no. I don't know how long this is going to take. Because my laptop's old too. If you start seeing any like choppy graphics, it's because it's trying to run this. I reduced the quality of my camera as well, just to make sure that, oh yeah, it's not doing that much overhead when it's like trying to do anything. Mate. Oh. I could make a readme in this tab. You know what? I'm going to search up some readme stuff. Awesome readme. This one? There we are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Articles, tools, there we go. I'm opening up examples when I could have just been opening up tools. There we are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There we are. Let's have a look. Amazing GitHub template, same defaults for your next project. Built with GitHub Fluid Markdown. Okay. That's for Node. That's stats. I'm pretty sure I've used this before. If you haven't checked this out before, it basically lets you compile your... Why is it not going to... Oh, has he taken it down? That's unfortunate. That's a decent template. Does it only work with Node? That's unfortunate. Let me just see. I think that's all. I don't think it actually like is supposed to do anything. I don't like it. Didn't like anyone. Okay. Had no idea what I was supposed to do. Didn't even see any of this. Like, did it load to the database anyway? GPU explicitly configured GPU to view default database queries and performed during the rendering tone cut. Started on port 8080. No. To wrap your repository with. Okay, so. Subject is. Getting started. Git push. Why are you like this? There we go. Compare and pull. Create pull. Let me go to settings. Cool. There we go. That should be updated, so if I just change this to master. There we go. That's a lot better. So that was part 1. Let's go on to part 2. So to wrap your repository with a web layer, you must turn to Spring MVC. Thanks to Spring Boot, there is little infrastructure to code, so we can focus on actions. What's the time right now? 5 o'clock. So employee controller .java. Cool. And then copy this. So @REST controller indicates that the data returned by each method will be written straight into response body instead of rendering a template. An employee repository is injected by constructing by a constructor into the controller. We have routes for each operation: get mapping, post mapping, put mapping, and delete mapping, corresponding to HTTP get, post, put, and delete calls. Note, it's useful to read each method and understand what they do. Employee not found exception is an exception used to indicate when an employee is looked up but not found. So let's make an employee not found exception. When an employee not found exception is thrown, this extra tidbit of Spring MVC configuration is used to render a for. Response body signals that this advice is rendered straight into the response body. Exception handler configures the advice to only respond if an employee not found exception is thrown. Response status says to issue an HTTP status not found, i.e. an HTTP 404. Body of the advice generates the content. In this case, it gives the message of the exception. To launch the application, right click the public static void main in and select run. Or you do /gradle w clean, and then you do /gradle w oh, I could have just clean and then boot run. And then if I open up another terminal, how are you guys gonna be able to see this? Alacrity. There we are. Let me switch this to my whole screen. There we are, now you'll be able to see it. Okay. curl-v localhost /employees. There we are. So it's got TCP, it has get employees localhost mark bundle as, that's a 404. That's not got anything. Interesting. I wonder why. Mm-hmm. Hmm. Ooh, hang on. Build Gradle. No. It's Grade W. Shared. Cache. Oh, cool. It's just here. Ja. Carter. Where? Clean build boot run. Snapshot. Yeah, I was building it, the hell. I don't know why this isn't working. Let me try 16.3. Let me try this one. But where? I don't have it set anywhere. Let me check mode. Oh, it'll be in spring. It'll be in spring when it runs. That's probably why. That makes sense. Hibernate core. This also was moved to hibernate core. Let me use 6.1.6. Let me check what the repo is saying, because the repo might have a different start. Hang on, it's non-rest. This one, payroll application. That looks the same. Employee looks the same. Employee controller looks about the same. Employee repository looks the same. Not found exception looks the same. Not found advice looks the same. And load database looks the same. I wonder why. Whoops. On the user repository, why ain't you working? User entity, core repository. Let me just copy these two. Actually, let me copy these three. Com example payroll. That's one way to do it, isn't it? God damn it. Honestly, that means I can undo this because this didn't change anything. Whoops. Let me grab, what's it called? Hibernate Entity Manager. Entity Manager. Clean build boot run. Okay, let's have a look. What does it do? Yep. Okay. Hang on. 0 JPA interfaces. Inside JPA Entity Manager default Tomcat payroll application. Some payroll application user PID in Java main in payroll. Example payroll application falling back to default 1. SLC bootstrapping default. SLC, that's fine, that's fine, that's fine. Okay, let's have a look. What does this do now? Nothing. Okay, so let me see what else am I missing. Java column example payroll. So inside here it's got com example payroll, import org, and then that, and then Spring Boot application, right? Then inside employee, com example payroll, capital P, payroll. Cool, let's have a look now. Found one JPA interface, nice. So if I do this now, there we are, got him. Okay, so done that one. I think I done this one. Yep, this will yield. You can see preloaded data. If you try to create a user that does not exist, so /99 should return, could not find 99. Nice. This message nicely shows an HTTP 404 error with custom message could not find employee 99. It's not hard to show the current coded interactions if you're using Windows command line prompt to issue curl commands. Chances are that the below commands won't work properly. You must either pick a terminal that supports single quoted arguments or use double quotes and escape the ones inside the JSON. To create a new employee record, we used following command in the terminal. At the beginning specifies what the field is for the terminal. Control C, let me just see, Control Shift V. So that's just saying that the application type, the content type is JSON, and you're saying that then you want the name to be Samwise Gamgee and role Gardener. So what happens in here? Okay, that assigns a term ID, but it doesn't show any verbose here for updating it. So I'm assuming if I do a get, it'll return ID3, yeah. So this is a put for changing the role. Okay. So then if you curl again, it should say ring bearer at the end. Yep. Finally, you can delete. So, and then if you do that, it should not be there anymore. Now, if you look at it again, employee 3 could not be found. That's just if I do /3 could not be found. Yeah, this is all well and good, but we do have a RESTful service yet. If you didn't catch the hint, the answer is no. What's missing? Okay, so HTTP Part 3. To wrap your repository with a web layer, you must return to Spring MVC. Thanks to Spring Boot, there's little in infrastructure code. Instead, we can focus on actions. So, inside the controller. By the way, if you see me clicking in the wrong place, it's because my mouse is glitching out a ton right now, so I can barely see what's happening, but you guys can see my mouse fine. I think it's just like a problem with display link or something, but you guys probably don't see it like coming in and out. Don't know why. V T P, cool. And then let me just change this to com.example.payroll w. REST controller indicates that the data returned by each method will be written straight into the response body instead of rendering a template. An example repository is injected by a constructor into the controller. We have routes for each operation: get mapping, post mapping, put mapping, and delete mapping corresponding to HTTP get, post, put, and delete. No, it's useful to read each method and understand what they do. That's finding all of them, finding it, otherwise throwing a not found exception, returning the ID and mapping each employee to its name and role, and then saving it as an employee otherwise, or getting the ID and then saving as a new employee. And then deleting just deletes by ID is an exception used to indicate when employees look up but not found. Employee not found exception. Not found exception. long ID. When an employee not found is thrown, there's an extra tip of Spring MVC configuration used to return a 404. Could not find employee. Runtime exception. That's ID. Okay, not found. Response body not found. X get. Okay, signals that this device is returned straight into the response body. It configures the device to only respond if an employee not found is extra and thrown. Response status says to an issue HTTP not found. HTTP 44 body to launch application. Boot run. That's fine. Curl 99. That's fine. What makes something restful? Did I actually read over the same thing twice? I did. I'm fucking stupid. So far, you have a web-based service that handles the core operations of our employee data, but that's not good enough to make things restful. Pretty URLs like employees 3 aren't REST. Merely using get and post isn't REST. Having all the core operations laid out isn't REST. In fact, what we have built so far is better described as RPC, remote procedure call. That's because there is no way to know how to interact with the service if you publish this today. You'd also have to write a document or host a developer's portal somewhere with all the details. The statement of Roy's fieldings may further lend a clue to the difference between REST and RPC. I'm getting frustrated by the number of people calling the HTTP-based interface as REST API. Today's example is a solid social site REST API that is RPC. It screens RPC. There's so much coupling on display that it should be given an X rating, which needs to be done to make the REST architectural style clear on the notion that hypertext is a constraint. In other words, if the engine of application state and hence the API is not being driven by a hypertext, then it cannot be RESTful and cannot be REST API, period. Is there some broken manual somewhere that needs to be fixed? The side effect of not including hypermedia is in our representations is that clients must hardcode URIs to navigate the API. This leads to the same brittle nature that predated the rise of e-commerce on the web. Is a signal that our JSON output needs a little help. Introducing Spring HTOS, the Spring project aimed at helping you write hypermedia driven output. Hate OAS. So, hate OAS. Let me have a look. Hate OAS Gradle. There we go. So inside my build.gradle, I need to grab this. Og Spring Framework dot boot. It looks fine. Fuck it. Might as well. There we are. And then give us constructor behind Spring Framework hate you as and then render it as an acceptable format for client consumption. It is, oh, I know what I could have done. I'm so fucking dumb, aren't I? I could have yanked it, I could have printed it, then I could have changed this. I'm so dumb. I could critical ingredient to any RESTful service, adding links to relevant operations to make your controller more RESTful. Add links like this. Getting a single item resource. Employee's ID. So if I go into the controller, and it's this one, right? And if I go like this, and then I go like that, there we are. This is very similar to what we had before, but a few things have changed. The return type of the method has changed to employee to entity model employee. Entity model T is a generic container from Spring HRS that includes not only the data but a collection links. Link to method on employee controller.class 1 ID with self-rel. Ask that Spring HRS build a link to the employee's controllers one method and the flag self link to method on employee controller.class all with rel employees. Ask Spring HRS to build a link to aggregate root all and call it employees. What do we mean by build a link? One of Spring's HRS's core types is link. It includes a URI and a rel relation. Links are what power the web. Before the World Wide Web, other document systems would render information or links, but it was the linking of documents with this kind of a relationship metadata that stitched the web together. Roy Fielding encourages building APIs with the same technique that made the web successful, and links are one of them. If you restart the application and create the employee record of Bilbo, you'll get a single different response than earlier. Okay. So if we do the same thing with, I need to go up my stack, clean build boot run. I'm guessing it's going to fail because I haven't imported anything. There we go. Yep. Okay, let me just check this. In getting started. There we are. I just needed God damn it. I just needed this. And then over here. There we are. Let's have a look. Can it build? Ooh, interesting. Why? Method on. Rest. This one. Employee controller. There we are. Let me just grab this. Let me just whoops. There we are. that's nice. ID1, name, role, then links employee href to that, and then self-employed. Oh, that's nice. It's in reverse though. Shows not only the data elements you saw earlier, ID, name, and role, but also links. This entire document is formatted using HAL. HAL is lightweight media type that allows encoding not just data but also hypermedia controls, alerting consumers to other parts of the API they can navigate towards. In this case, there's a self link, kind of like this statement in code, along with a link back aggregate post. To make aggregate root also more restful, you want to include top level link while also including any restful components within. So we return this. Ooh, that's fancy. So all becomes this. Oh, whoops. God damn it. My copy got overridden, sorry. Let me just... There we go. Which used to just be repository of Final is all grown up, not to worry, let's unpack it. Collection model is another Spring HOS container. It's aimed at encapsulating collections of resources, serve a single resource entity like entity model from earlier. Collection model 2 lets you include links. Don't let that first statement slip by. What does encapsulating collections mean? Collections of employees? Not quite. Since we're talking REST, it should encapsulate collections of employee resources. That's why you fetch all the employees, but then transform them into a list of entity model employees. Objects. Thanks Java 8 streams. If you restart the application and fetch aggregate root, you can see what it looks like now. Let me just let that run. Yeah, nice. So if I just do that and then do, I think it's this, JSON underscore pp. Cool. So now it's got embedded employees, links, links, and links. So the first one is, okay. So for some reason it's pulling in the links first. Oh, I'm guessing it's ordering based on what's it called? Characters. So it's not ordering. So for example, underscore has higher precedence than a letter. That's why it's returning first. That makes sense. I was like, why is it returning like that? And that also explains why like underscore embedded is returning before underscore links. It's not doing it in reverse. It's just that underscore has a higher precedence than a letter. For this, I wrote root, which serves up a collection of employee resources. There's a top-level self-link. The collection is listed underneath the embedded section. This is how HAL represents collections, and each individual member of the collection has their information as well as related links. What's the point of adding all these links? It makes it possible to evolve REST services over time. Existing links can be maintained while new links can be added in the future. Newer clients may take advantage of the new links, while legacy clients can sustain themselves on the old links. This is especially helpful if the services get relocated and moved around. As long as the links structure is maintained, clients can still find and interact with things. Simplifying link creation in the code. That's it for this one. Let me just scroll up. There we are. Okay, so simplifying link creation. In the code earlier, did you notice that repetition in single employee link creation? That code to provide a single link to an employee as well as to create an employee's link to aggregate root was shown twice. If that raised your concern, good, there's a solution. Simply put, you need to define a function that converts employee objects to an entity model employee objects. While you could easily code this method yourself, there are benefits down the road of implementing Spring's HOS's representation model assembler interface, which will do the work for you. Okay, so if I copy this and then change this to there we are. The simple interface has one method, toModel, is based on converting a non-model object employee into a model-based object entity model employees. All the code you saw earlier in the controller can be moved into this class, and by applying Spring Framework's at component annotation, the assembler will be automatically created when the app starts. Abstract base class for all methods is, but for simplicity, I recommend using entity model as your mechanism to easily wrap all POJOs. To leverage this assembler, you only have to alter employee controller by injecting the assembler into the constructor. So if I go into the controller, repository, and then you have the assembler, employee assembler, that's a good thing in it, because I just noticed that I've named it badly. Rename. There we are. Employee model assembler. Assembler. From here, you can use assembler in single item employee method. So in this one, nice. There we are. The code is almost the same, except instead of creating the entity model employees instance here, you delegate it to the assembler. Maybe that doesn't look like much. Applying the same thing in the aggregate root controller is more impressive. There we are. The code is again almost the same, however you could replace all that entity model employee creation logic with map assembler to model. Thanks to Java 8 method references, it's super easy to plug it in and simplify your controller. A key design goal of Spring HOS is to make it easier to do the right thing In this scenario, adding hypermedia to your service without hard coding a thing. At this stage, you've created a Spring MVC REST controller that actually produces the hypermedia powered content. Clients that don't speak HAL can ignore the extra bits while consuming the pure data. Clients that do speak HAL can navigate your empowered API, but that's not the only thing needed to build a truly RESTful service with Spring. So, if I clean build, let's have a look. Is it able to build? I'm guessing I'm missing an import. Apparently not. Cool. So let me just do this. Nice, works fine. Cool. Evolving REST APIs. We're about halfway through. With one additional library and a few lines of extra code, you have added hypermedia to your application, but that is not the only thing that needs to make your service RESTful. An important facet of REST is the fact that it's neither a technology stack nor a single standard. REST is a collection of architectural constraints that, when adopted, make your application much more resilient. A key factor of resilience is that when you make upgrades to your services, your clients don't suffer from downtime. In the olden days, upgrades were notorious for breaking clients. In other words, an upgrade to the server required an update to the client. In this day and age, hours or even minutes of downtime spent doing an upgrade can cost millions in lost revenue. Some companies require that you present management with a plan to minimize downtime. In the past, you could get away with upgrading at 2 a.m. on a Sunday when load was at a minimum. But in today's internet-based e-commerce, with international customers in other time zones, such strategies are not as effective. SOAP-based services and CORBA-based services were incredibly brittle. It was hard to roll out a server that could support both old and new clients. With REST-based practices, it's much easier, especially using the Spring Stack. Supporting changes to the API. Imagine this design problem. You've rolled out a system with this employee-based record. The system is a major hit. You sold your system to countless enterprises. Suddenly, the need for the employee's name to be split into first name and last name arises. Didn't think of that. Before you open up the employee class and replace the single field name with first and last name, stop and think for a minute. Will that break any clients? How long will it take for them to upgrade? Do you even control all the clients accessing your service? Downtime equals lost money. Is management ready for that? There's an old strategy that precedes REST by years: never delete a column in a database. Unknown. You can always add columns, fields to a database table, but don't take one away. The principle in RESTful services is the same. And new fields to your JSON representation, but don't take away, like this: first name, last name, role, and their whole name. Notice how this format shows first name, last name, and name. While it supports duplication of information, the purpose is to support both old and new clients. That means you can upgrade the server without requiring clients upgrade at the same time. A good move that should reduce downtime. And not only should you show this information in both the old way and the new way, you should also process incoming data both ways. How simple, like this: employee record that handles both old and new clients. And then this. It should be fine. This class is very similar to the previous version of employee. Let's go over the change. Field name has been replaced by first name and last name. A virtual get out for the old name property get name is defined. It uses the first name and last name fields to produce a value. A virtual setter for the old name property is also defined. Set name, it passes an incoming string and stores it in the proper fields. Of course, not every change to your API is as simple as splitting a string or merging two strings, but it's surely not impossible to come up with a set of transforms for more scenarios, right? Don't forget to go and change how you preload your database in load database. There we go. There we go. Proper responses, another step in the right direction. Oh, what? Is that another one? Supporting changes. That's big. Proper responses. It hasn't said to run it yet. I'm gonna take every time it says run it as like, oh, this is a new change. Another step in the right direction involves ensuring that each of your REST methods return a proper response. Update the post method to be like this. So that's in the employee controller. And then I just need to copy this post. That's post mapping. There we go. Ah, shit. There we go. The new employee object is saved as before, but the resulting object is wrapped using the employee model assembler. Spring's MVC response entity is used to create a HTTP 201 created status message. This type of response typically includes a location response header, and we use the URI divider from the model self-related link. Additionally, return the model-based version of the saved object. With these tweaks in place, you can use the name endpoint to create a new employee resource and use legacy name field. So if I clean, build, and boot run, let's see if it fails. Nice. Ayana link, response entity. Ooh, interesting. That's in the employee controller, and that doesn't have a response entity. Nande. It doesn't use it in here. That's interesting. What did I update to use response entity? Employees for post. No. That's inside repository. Nah. Hontoni sage. I want to check the history of this file. Use response entity. I'm guessing I'm just gonna have to write out the import, aren't I? Iona link relations. Ah. Ooh, interesting. What's wrong? Illegal arguments. None there. Where does the repository come from? Let me check load database. Yeah, repository. None do. What's wrong? Payroll applications test. Context loads. Ah. Not cargo. It's the test. I could skip the test if I need to. You know what? We'll just continue on because I don't want to deal with this right now. Another step in the right direction involves ensuring that each of your REST methods return a proper response update. That's fine. This not only has objects rendered in HAL, but also location header populated with local host 8000 employees. A hypermedia powered client could opt to surf to this new resource and proceed to interact with it. The put needs some simple tweaks. Cool. There we are. The employee object built from the save operation is then wrapped using the employee model assembler into an entity model object. Using the get required link method, you can retrieve the link created by the assembly modeler with a self-rel. This method returns a link which must be turned into a URI with two URI. Since we want some more detailed HTTP response code, then 200 will use Spring MVC's response entity wrapper. It has a handy static create when we call. Okay, so run with it. Employee response resource has now been updated and the location URI sent back. Finally updated in the delete operation. Cool. Making changes to the employee class will require the coordination with the database team so that they can properly migrate existing content into the new columns. You are now ready for upgrade that will not disturb existing clients while newer clients can take advantage of the enhancement. I just want to see, do they even have a Gradle in here? No, they only got freaking Maven. Damn it. I can check that Palm XML. Oh, wrong Palm XML. They got boot, they have web and JPA, they have HOS, and they've got the Maven plugin. Interesting. So I'm not missing anything. So far, you've built an evolvable API with barebone links to grow your. Okay, so let me just check. Will this work now? I'm guessing not. Fail. Yeah. Why? Ooh, what's this? employee repository. Let me check. What does it put in the repository? Nothing. Well, let's just keep going. So far, you built an available API with bare-bone links. To grow your API and better serve your clients, you need to embrace the concept of hypermedia as the engine of application state. What does this mean? In this section, we'll explore in detail. Business logic inevitably builds up rules that involve processes. The risk of such systems is we often carry such server-side logic into clients and build up strong coupling. REST is about breaking down such connections and minimizing such coupling to show how to cope with state changes without triggering breaking changes in the client. Imagine adding a system that fulfills orders. As a first step, define an order record. Okay. Order Java. Okay, let me copy this. The class requires a JPA at table initiation, changing the table's name to customer order because order is not a valid name for a table. It includes a description field as well as status field. Orders must go through a certain series of state transitions from the time a customer submits an order and is either fulfilled or cancelled. This can be captured as Java enum. So, status. This enum captures the various states an order can occupy. For this tutorial, let's keep it simple. To support interacting with orders in the database, you must define a corresponding Spring Data repository. Order repository, okay. Order repository.java. There we are. Let me just grab everything from this. Yank. Print. And that should extend order. There we are. With this in place, you can now define a basic order controller. Cool. Let me just grab this V G yank order controller P. Cool. Change this order controller. Change to order repository. Delete this order controller. I just realized I might need to do that somewhere else. Controller. Nope. Order repository. There we are. And then I need a REST control. Oh, it done it for me. Lads, it's long. It contains the same REST controller setup as the controllers you built so far, injects both an order repository as well as not yet built order model assembler. The first 2 Spring MVC routes handle the aggregate route as well as a single item order resource request. Third Spring MVC route handles creating new orders by starting them in progress state. All controller method returns one of Spring HTOS's representation model subclasses of property render hypermedia or a wrapper around such a state. Before building the order model assembler that success what needs to happen, you're modeling the flow of state between status in progress, status complete, status cancelled. A natural thing when serving up such data to clients is to let clients make the decision on what it can do based on what this payload, but that would be wrong. What happens when you introduce a new state in the flow? The placement of the various buttons on the UI would probably be erroneous. What if you change the name of each state, perhaps while coding? International support and showing local specific text for each state. That would most likely break all the clients. Enter HOS or hypermedia as the engine of application state. Instead of clients passing payloads, give them links to signal valid actions. Decouple state-based actions from the payload of data. In other words, when cancel and complete are valid actions, dynamically add them to the list of links. Clients only need to show users the corresponding buttons when the links exist. This decouples clients from having to know when such actions are valid, reducing the risk of server and its clients getting out of sync on the logic of state transitions. Having already embraced the concept of Spring hypermedia as the engine of application state, representation model assembler components, putting such logic in the order model assembler would be perfect place to capture the business rule. Order model assembler. What? Ja. Jesus, this is a lot. Let me just change this to com.example.payroll. Cool. This resource assembler always includes a self link to the single item resource as well as a link back to the aggregate route, but it also includes 2 conditional links to order controller.cancel ID as well as order controller.complete ID. These links are only shown when the order's status is status in progress. If client can adopt HAL and the ability to read the links instead of simply reading the data plain old JSON, they can trade in the need for domain knowledge about the order system. This naturally reduces the coupling between client and server, and it opens the door to tuning the flow of order fulfillment without breaking clients in the process. To round out order fulfillment, add the following to the order controller for the cancel operation. Get post and delete. There we are. It checks order status before allowing it to be cancelled. If it's not a valid state, and it returns an RFC 7807 problem, a hypermedia supporting error container. If the transition is indeed valid, it transitions to the order to cancelled, and add this to order controller as well for order completion. So that's a put. Delete. Let me just put this underneath. There we are. This implements similar logic to prevent an order status from getting completed unless in a proper state. Let's update the database, preload some orders along with employees, update the database preloader. This is load database. There we are. Now you can test things out. To use it, the HAL document immediately shows how different links for each order based upon its present state. First order being completed. Okay, the response shows this. If you try the same operation, if you see that summary throughout. Okay, let me ballerina pro client can be okay. Let me go to top rest. Links evolution. This one. That doesn't have it. Links. This one. There we go. So, I just need to grab everything, to be honest. C VG P dot example dot payroll. There we are. Now let's do the same thing for employee controller. Model assembler. Not found device. Not found exception. Employee repository. Load database. Order. Order controller. Order model assembler. Order not found exception. So here's where some stuff. Order not found exception. Just wasn't there. Order not found exception. Order repository. Payroll application. status. Oh, there's a root controller. What does this do? This gets the index and makes a representation model. If that model, so it just adds the controllers to that model and then returns it. So the index page just returns employees or orders. So it just registers the controllers. So it's like a page router in React, I think. And then this. So 0 VGP change that com.example.payroll. So let's see, will it build? I don't know. Interesting, why not? Let me have a look at the problem. Hang on. So that's model version 4. Group ID 0.01 snapshot, that's fine. 0.01. It has web, boot starter web. It has JPA. It has HOS. Then it has COM HUD runtime. Then it doesn't have anything else. So it doesn't have Hibernate. Let's see. I don't even think it would build without me specifying Hibernate. What's this? Package Java X persistence does not exist. Doesn't exist. Hibernate Entity Manager, right? And then artifact was moved. Okay, org Hibernate. Hibernate core relocation. So this has the most utilizations. This one, so there's this. Wait, what is this? Is this a beta package? No, I'll use a final. It's fine, I'll use a final. Let me just build. What is it? Java X persistence does not exist. Okay, I know what I can do. Jakarta. I just want to see that it fell for the same reason. That's generated value. What's it up on here? Entity, there we go. Persistence. Let's try this now. There we are. Clean build boot run. Let's have a look. Will it run? I don't know. Alright, let's have a look. If I do employees, should return Bilbo, Baggins, and that. And then if I do orders, should return iPhone and MacBook Pro. Nice. Cool. So throughout this tutorial, I've engaged in various tactics to build REST APIs. As it turns out, REST isn't just about pretty URIs and returning JSON instead of XML. Instead, the following tactics help make your services less likely to break existing clients you may or may not control. Don't remove old fields instead, support them. Use rel-based links so clients don't have to hardcode URIs. Retain old links as long as possible, even if you have to change your URI. Keep the rel so older clients have a path onto the newer features. Use links, not payload data, to instruct clients when various state-driven operations are available. There may appear to be a bit of extra effort to build up representation model assembler implementations for each resource type, and to use these components in all of your controllers. But this extra bit of server-side setup made easy thanks to Spring. What's it called again? Hypermedia as the engine of application state. Hypermedia as the engine of application state. Hypermedia as the engine of application state. Can ensure the clients you control, and more importantly those you don't, can upgrade with ease as you evolve your API. This concludes our tutorial on how to build RESTful services using Spring. Each section of the tutorial is managed as a separate sub-project in a single GitHub repository. Now a simple single MVC app with no hypermedia, Spring MVC plus Spring hypermedia as the engine of application services. App. I can't remember it now. Vicinity resource, REST API app where field is full but all data is retained for backwards compatibility, REST app where conditional links are used to signal valid state changes to clients. To view more examples of Spring HATEOASC examples. To do some more exploring, check out the following video by Spring teammate Oliver. Want to write a new guide or contribute to the existing one? Check out our contribution guides. Cool. So that is this one. Done. I have 1, 2, 3, 4, 5, 6 left. Cool. I want to see if I can host this somewhere. Host Spring repo. Story Spring. GitHub. Netlify. Heroku alternatives. Awesome Free. GitHub. Free for devs. There we go. Crew. Netlify. Spring. Java. Server. Where's Netlify? Okay, so Netlify is under CMS. It's under code searching. And it's under web hosting. Nice. Anyway, I'm going to try deploying this somewhere. Let me just create pull request. Merge. There we are. So if there we are. So if I control W. Anyway, thanks for watching. If you liked the video, please like, subscribe, enjoy the rest of your always pointing here, innit? If you liked watching me and you want to see more videos like this or live streams like this, comment down below. Other than that, thanks for watching, like, subscribe, enjoy the rest of your day, and peace.